Okay, so I'm going to take you through the agenda for the day, and then from there we are going to look at what Samuel has prepared for us today. So the first thing that we are going to look at before we go to the agenda is the quote of the day, is which says that success is hidden in your daily routine. So what you do on a daily basis will determine uh, what achievements you can make, because success is on a basis of small things that you do iteratively. So we can move on to the agenda where we are going to look to have an icebreaker, and then you are going to have I'm going to share with you some meeting expectations. Then the new members are going to get the chance to hear from us about the community. Then after that, you're going to learn about private cloud infrastructure. After which, we are going to have a question and answer session. So the first thing, we move into our icebreaker. And the icebreaker that we have today is how many times do you snooze your alarm? And what can make you wake up even before your alarm? So you can type on the chat, and you can also raise your hand, and I'll be able to give you a chance to speak. So how many times do you snooze your alarm in the morning when you're waking up? And what can make you wake up even before the alarm rings? So let me see you commenting on the chat, looking at the chat. So Eric was the first one to respond there, saying snoozing 3 times, and the M-Pesa message can wake you up even before the alarm rings. That is very interesting. So and then Michael says Jaya usiku. Okay, that is very interesting. So yeah, nobody can resist that. So do we have any other people who would like to comment, or anyone who would like to unmute? Anyone would like to unmute? Anyone? Going once? Going twice? Okay, so let me go ahead and share. So me, I think it depends on what I'm waking up to do. So if it's not very something I've not prioritized, I can snooze and snooze until I postpone. But if it's something I've prioritized, if the alarm rings once, I'll be awake. So, and what can wake me up even before the alarm rings? Maybe if I'm going to an event or something of the sort, or I'm traveling, going to a place I've been anticipating to visit. Such things can make me wake up before the alarm. So I see here Susan said snoozing 5 to 10 times, and then hunger is the only thing that can make wake up in the night before the alarm. Then we have Jerry, who says, I don't snooze. I believes he can always wake up in time. So do you even set alarms, Jerry? Okay. So Jerry says he doesn't set alarms. Okay. So your mind must be very strong. So I think we can proceed to the next thing, which is in-house rules. So in case you want to, as the meeting goes on, you're expected to mute yourself when you're not speaking. And in case you want to speak, you're expected to raise your hand, and you'll be given the permission to speak. You can use the chat box to write comments or questions during the session, and then they'll be answered at the end. You're also expected to be respectful and be curious so that you can be able to ask questions. Yeah. So those are the in-house rules or meeting expectations. About the community. So our community is a DevOps-based community that contains both DevOps beginners and DevOps experts. And our goal is just to ensure that we can make people aware about DevOps and allow those who are new to DevOps to learn, allow those who are experienced to share, and allow people to network and grow. So that is why we have this community. And the mission is just to create a supportive and inclusive community that values diversity and supports learning and growth. And then the vision is to be a leading DevOps community in Nairobi and beyond, driving innovation and empowering professionals to excel in their careers. We have a team that is responsible for ensuring that we have these events that we have. And this team is the one that plans and organizes everything to ensure that we can be able to achieve the vision and the mission of the community. So in case you want to help, you can help us by volunteering to offer a talk or run a workshop for the community members. And then you can also connect us with other DevOps professionals. You can also connect us with companies you think we can partner with. You can give us feedback on ways we can improve, and you can share ideas on how we can make the community better. And feedback can also contain things you don't like as well. You can help us by sharing our posts on our channel. So if we post, for example, on LinkedIn, you can repost. If we post on WhatsApp something, you can just share that on your status. On Twitter, you can retweet as well. So that is how you can help us. You can also help us in documenting activities. So documenting maybe something like helping us write minutes, helping us when we have events to capture photos or videos and such things. You can help us in organizing events, and yeah, and something that is not actually even in creating posters. We also are working currently on our website. So if you are interested, you can help us in that way. You can join us and join the team and help us in creating the website. So we have a website, but it's not a good website. Now we are creating a better one. So today we are going to be taken through private cloud infrastructure, and the speaker of the day is Samuel Wambugu. So at this moment, I would like to invite Samuel. So Samuel, if you don't mind, are you able to hear me, Samuel?
Yes, I can hear you, Kadima. Can you hear me?
Yeah, good. So welcome. The floor is yours now. You can. I'll stop sharing
Asante.
yeah, I'll stop sharing the screen so that you can take over.
Okay.
Okay,
Thank you,
good.
thank you, thank you, Kadima.
You're
Um,
welcome.
Good to see all of us. Uh, yes, let me just share my slides here. So, as Kadima mentioned, my name is Samuel Wambugu, for those whom we have not met. Um, yeah, I'm a, I'm a DevOps engineer. With a bit of a background in infrastructure as an cloud infrastructure engineer. So, in fact, I think for the most part of my career in IT, I have been on the side of infrastructure more than I have been in the side of DevOps. Yeah, and I hope this will be an interactive session, a fun one, and we will also learn, yeah, as you also have fun in looking at this at these concepts. So allow me to share my screen just a sec. So you see, share screen. Uh, Let me know, Kadima, can you see my slides?
Yes, I can see your slides.
Perfect, perfect. So yeah, so they when you think about cloud and particularly private cloud, there are many technologies you can use for that, but my plan today is that we will use one of them, or actually several technologies that have been created by one company called VMware. So my plan is for us to use this as just a starting point for us. And then, but these concepts actually apply. There are many other companies which have built products that can help you in building private clouds. But VMware, I think, by far is the most known. Um, yeah, so just to help me be able to be able to know what to, or the extents to go in this, I would maybe love to know how many IT infrastructure engineers do we have in the house. Maybe if you're an infrastructure engineer, IT infrastructure engineer, maybe you can show us by just pick raising your hand. That would be very helpful for me. um any infrastructure guys, hardcore. When I mean hardcore, is like you deal with infra day in, day out. Servers, people also call them system admins. Uh, Perfect. Michael, I can see you there. Uh, yes. Anyone else there? Infrastructure engineer hapo. Wala tunalalanga kwa data center sometimes. Anyway, well, I don't nowadays. I don't sleep in data centers, but I have done so some 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 years back. So now for okay, thanks Michael for your hand. Uh, yeah, so I would think then what that would mean is probably Michael has worked with VMware. I'm not sure. He can tell us on the chats. Uh, he has worked with VMware and what was or what are his or probably he's currently working with VMware and his favorite technology. So let me just build some context for us. VMware is a company which is an American cloud computing company. It's best known for its virtualization software. VMware have not paid me anything to market them. I just love their products, so I'll just put it out there. Yeah, they're awesome. They The simplest way to understand VMware is I think of it as again, do not quote me anywhere in your publications on this, but personally I love to think of VMware, or it helps me understand VMware better when I think of it as being the Microsoft of servers. When I say Microsoft of servers, is like Microsoft is best known for Windows, which is an operating system that runs on laptops, personal computers. Now, VMware is best known for software or operating systems that run on an operating system actually that runs on servers. So Microsoft known for PCs mostly. You can think of it. It's just so broad. We have Windows servers inside there, but Microsoft is mainly known because of Windows, which is an operating system that runs on personal computers. VMware, on the other hand, is best known for an operating system called ESXi, which runs on servers. So just to show you how far this can go, most banks, hospitals, and big organizations which have lots of computing, or they have a lot of computing power, or they need a lot of computing power to run their businesses, they will normally have VMware as the underlying virtualization technology that they're using. So I don't know whether Michael alituwekea kwa chat kama amefanya na VMware. Let me check. Yes, I still work with VMware. So Jerry pia, Jerry Juma has also worked with VMware. No worries. If you haven't worked with VMware, this will be. I hope this will be a good introduction to how it works and how you can use it. You might find yourself using it in the future, maybe in your future roles, or you can even start using it if you haven't been using it. So VMware was founded in 1998. As the slide there shows. So I think let's go ahead. So by the end of this, let me just throw uh, some path on what we will do. So at the end of this video, at the end of this presentation, we will do a small a demo. So I have a lab that I have, where there's an ESXi, some several ESXi hosts. Basically, let me not make it complicated. Think of it as physical host. So a physical server that you can touch and smell, and yeah. So I've set up a lab that emulates four physical servers, and then set up some ESXi inside them. As you mentioned, ESXi is like the operating system that runs on them on the bare metal. And then now ESXi is a hypervisor, which a hypervisor is a software, is an operating system that allows you to run other operating systems on top. So what ESXi allows you to do is to run now Linux virtual machines. You can run Windows virtual machines, and it's an awesome product. I love it. I love it. It's amazing. I hope you will get to see by the end of this thing. Um, let's go to the next slide here. So, I think I'll rush a bit. So, by a show of hand, anyone who has been into a data center in this group, I want us to see a show of hand. I know there are several. Nairobi, we have, I think the major ones, there are four. In Mombasa, I think we have several. Anyone? DC, unaweza tuwekea jina ya DC yenye ulienda, and what stood out for you? Data center manenos, nimesikia some chat hapa. Oh, Kenneth, well, I have not been to Kenneth. I would love to know where it is. Peter, you can just type a bit on where it is and what stood out for you for the data center. Oh, SICOM. No, SICOM. Okay, SICOM have a data center. Okay, guys. Okay, I'm not sure about this, but I know of only three data centers in Nairobi. There is Africa Data Center. It's behind Samia Business Park. The reason I'm telling you this is because it will come in, and or I'm trying to gauge how far will I go with this discussion. But data centers are key for IT. Like you can't have. We wouldn't have Facebook if there are no data centers. We wouldn't have TikTok if there are no data centers. We wouldn't have Google itself if there are no data centers. So there are several in Nairobi which allow us then as IT uh, guys within the region to be able to do stuff that we would not be able to do if the data centers were not there. And the key thing is redundancy, where now what I have mentioned at the end of this presentation, I'll show you a lab where we have 4 physical hosts. Normally for those 4 physical hosts, you wouldn't want to have them in your home. Why? Because KPLC does their thing and your systems will go down. And if you have an application, probably it's a critical one, maybe it's a hospital management system, patients cannot be queued, doctors cannot make notes. It's crazy. So you will want to have that in a data center. So that's why I'm asking about the data center a bit. I hope you see how they relate. The data centers are at the heart. So they are the physical infrastructure, the warehouse that, where you come in and put your physical servers, and then uh, now from the physical servers you set up the operating system. Like now, for example, we will use VMware's technologies, we will use ESXi, and then on top of now those virtualization technology, you set up your virtual machines, and then on top of the virtual machines, then now you can give your developers access to that. Guys can be able to deploy their VMs, their applications there. If you want to do Kubernetes, amazing, you can do it. There is several things. It's amazing what you can do. I get very excited when I'm talking about these things. But let's go to the next. So the objectives for this um, uh, for this uh, for this session, I'll move a bit faster, is to understand a bit of how the cloud works. I know you guys know these things, but okay, maybe for the ones who getting started, just to explain a bit, and you can get a glimpse of how the cloud works, what happens behind the curtains, what do we have behind there. When you spin up an EC2 instance, on AWS, what's happening, where is that EC2 instance, and how, what is the infrastructure behind that is supporting that EC2 instance. There's a physical server, not even one. There are many of them, and they have been set up in a way that they will allow you to set up that EC2 instance. And amazingly, they have also been set up in a way that that EC2 instance cannot go down, or is not supposed to go down. And it's about redundancy. So redundancy is at the heart of how the cloud is built. So you don't build a cloud with a single server, you build with many servers, and then not only many servers, but when I say servers, I mean physical ones, not not one, but many. And then there's a way that you set them up to make sure that you your applications are always online. Not only not applications really. For system admins, we don't they don't deal so much with the applications, but they deal more on the infrastructure itself. They make sure that the virtual machine is always online. Then the software developer, on the other hand, has to make sure that the software is always online in a sense, or in a bugs and stuff, etc. So our objectives then is to see to explain a bit what is a private cloud. I hope to make it interactive still, and then why why you may need a private cloud, what makes up a private cloud. We go to the live demo and we do a Q&A. So okay, so I have already given you tips on what is a private cloud. So let me rush through this. A private cloud is basically a group of managed physical machines, mainly servers and switches, and then everything else can be virtualized. When I mean that is routers and even switches themselves can be virtualized to some extent. So a private cloud is, like I remember when I was in school some years back, in campus we had a server room, a huge one, in one of the buildings in the campus. uh, but it never dawned to me, why do you even need a server room and stuff? No, yeah, I always thought, okay, see, you just build your application and push it somewhere on a C panel, and you're done. Or even for virtual machines, I came to learn about them way later after school. So, but it dawned on me that for institutions, then it's important to, like the campus that I was schooling at, uh, there are other things, there are other business factors that come in, that now especially to do with expenses, revenues. Like for any organization, you have to look at your expenses, you have to look at your revenues, and those are the two main things that you look at. If it's a profitable organization, you want to make profit, so you have to check on your expenses a lot. You guys, as you already know, the cloud can be a bit expensive at times. And not only being expensive, sometimes I'm not crucifying public cloud, do not take me wrongly. I use public cloud big time. Like I spend most of my time on GCP, but it can get a bit expensive. You guys know the memes that go around about, hey, ukiwacha EC2 on, you're in trouble. So yeah, so one of the reasons that you might need a private cloud, or a company might need a private cloud, like a server room. Or nowadays people are not doing server rooms a lot. So, they're now going into data centers. Like for example, for many banks in Kenya, you don't find, you probably they will have some few server rooms somewhere. If you work for any of the banks, do not crucify me if this is not entirely accurate for your case. But yeah, for the most of them that I know of, that they hosted their physical servers in data centers. And as I mentioned, in Nairobi, I think we have three. In Mombasa, we have a few also. So they will host there, and the reason why they will host there not in a server room is because of redundancy, especially around power. With Kenya Power and what they do, now you have to give that headache to someone else. Data center, you guys sort out my servers, I want them to be always online. But that's the only thing that the data center will do. They'll provide you with power, cooling, and security, and connectivity. Those four things: power, cooling, connectivity, and security. Then for you, you have to figure out how to set up your servers to make sure they are redundant. So anyway, so let me rush a bit. I've already explained why a company would need. So managing infrastructure costs as one. Provide reliability from an infrastructure perspective. Flexibility. Policies, data residency. Sometimes, like for if you follow the news keenly, like in the UK, there are a few things that are happening around data and policy making. So kidogo kidogo, you can hear, you can, there's a law that might come up, that you can't host personal data for Kenyans outside Kenya, and then now you have a problem if your application stores email addresses and phone numbers for your users. Then the government now is coming and saying, hey boss, for that data that you have, for you have phone numbers and email addresses belonging to Kenyans, we want it to stay in Kenya. Then at that point, then you're like, now I can't do EC2, or now I can do GCP. Hopefully by then these guys will have set up, like real regions in Kenya, that I highly doubt. But even if they do, then depending on the time that might happen, then you still have the issue of cost, because yeah, public cloud can be costly. So I had so many notes on this thing, but I'm just talking, so I hope it's helpful. If you want me to stick to the slides, I could, but I think this is a more better approach. I hope I'm not bombarding you too much with too much info. I'm not going into great depths. If you have any questions, please chat me. If you want me to clarify on something, please write it on the chat. If you want me to to go back on something I've said, and just explain it a bit better, I'll do that. So yeah, so that's it. So custom business needs, I think for this one, and I was writing this down, my mind went to, for example, hospitals. Unfortunately, I frequent, I'm a frequent visitor of hospitals for clinics, for me and for my family sometimes. And you see like the systems that they use, um, and like uh, you know uh, that system is very critical in terms of, if there is a hitch, and depending on the size of the hospital, it can have a very negative experience on the patients. Like I remember I have gone to a hospital in Nairobi and I stayed for a whole day. I just had a stomachache kidogo, but I stayed for a whole day. I won't mention the hospital, but I stayed for a whole day. And those guys, they didn't. It's a big hospital, but they actually, even I don't think even they had a system. For them, they were moving files around. And I was seeing the doctor in the evening, and I had gone in the morning. I decided I will never go back to that hospital ever again. So, but the point is here: if that system has a small hitch, you have a problem, because patients cannot see doctors cannot make notes. It's crazy. If the hospital is a big one, it's crazy how that can have an effect on even how much, how many patients are seen in a day. Everything is managed on that system. If it's the surgical team, they are scheduling operations on the system. If it's a pharmaceutical team, drugs are being dispensed on the system. So for these guys, like for them, one of the hospitals that I normally frequent, which is awesome. This is an awesome one. It's somewhere along between Nairobi and Nakuru. It's called AIC Kijabi. So AIC Kijabi, if you have ever gone to that hospital, it's very well. It's a bit far from the main road, from the highway, and that is Nairobi Nakuru Highway. So, and sometimes probably thinking to myself, there might be internet connectivity issues. Like for example, that hospital is a big one, but their connectivity to the internet is wanting a bit. So if that hospital, to take it as an example, if they had their systems on Google Cloud, you can imagine how crazy that can get. Because someone decides along Westlands they are going to watachimba barabara hiyo siku, wakate cable bahati mbaya, and then now patients at AIC Kijabi cannot be seen because there's a fiber cable that imekatika Waiyaki. So for such a hospital, then it makes sense to have the infrastructure there, which they do. So their hospital management system is hosted in a private cloud. I hope now you see how I'm bringing this together. It's hosted in a private cloud in the hospital because they want to have the patient data there, and they also want to have the system there. So they don't rely on connectivity to, they don't rely on an internet service provider. Well, they have internet service providers, but not for their core hospital management system. So for that, they don't need any internet service provider. They have done their trunking, they have connected their switches, their server rooms, and everything, and they have built their redundancy within that private data center, which is basically now server rooms, and everyone is connected to everyone else in that hospital. So the pharmacies, which are several of them, they're connected to that one system. Has even hospitals within itself. It's crazy, You get into the hospital and then there's another hospital within it. If you have been there, you might know what I'm talking about. They have hospitals within the hospital. So you can imagine how that complex, how that system is complex, and all that is hosted there. So when I mean custom business needs, that's like a custom business need for that particular hospital, because for them, it's key for them. They want the system to be always online, and they can't afford to have it in a public cloud because there are so many moving parts for that. So, and data residency might be another issue. That's patient data. You don't, some people are still, like, inaenda wapi iende. So I'm storing my patient data for guys here. It's going all the way to the US just to store in GCP. That's a problem for them. So they would want to have it there. Anyway, so is there any question up to that point? Any question? Any any clarification that you might need? Just write it on the chat as we move ahead. I want to move a bit faster. Ooh, we only have 20 minutes. I should be now on the demo. So let me move faster here. I'll go all the way to the demo. Let's see. So what makes up a private cloud? Guys, I have already given you hints for this one. But I want, guys, yeah, I've already given you hints. Let's not waste time on this one. I don't like what I'm doing because on this, I had planned to ask these questions: what makes up a private cloud, and then you guys get to chat. But I have already given you some hints. But maybe I should go back and let you type. But anyway, let's just proceed. So yeah, so private cloud again, servers. I hope it's not boring. It's not a lecture. Anyway, so there are servers, there are switches, there are routers. Routers could be physical, they could be virtual. There are hypervisors. Hypervisors is a operating system, as we said, that allows you to run other operating systems on top of it. And we have supporting infrastructure like power and connectivity. So I want to give you a story a bit before we go to the demos. And this is about the last point there: supporting infrastructure, power, and connectivity, redundancy. Uh, so I saw maybe a few guys there wrote that they have been into data centers. So the main ones I would think that we have in Nairobi, there are three of them. Probably our DevOps team could plan for a visit for us. I'll be more than willing to try and help facilitate that for us to just, they are more than willing to host people, and we can do a tour. They actually do tours and show you how much investment that has gone into setting up the data center in terms of the infrastructure that they have built. So let me explain a bit, like, for example, for the power bit. It's very interesting how this has been built. So if you guys have worked with physical servers, you know that behind the server there, you normally have two power supplies. So a server will have two power supplies. So what happens is, then, from that point, from where that power, you connect one power supply to, now a server is normally in a rack. Hopefully you have seen a rack. A rack is like a shelf, and then you know you have seen these movies probably, even if you haven't seen a real one. So it's there are black shelves, and then you put the server inside. So a server normally behind there it has two power supply units. Those two power supply units, one of the power supply goes to like it's like a huge uh, uh, connection, like a huge extension. Think of it as an extension, come a steamer on the left, and we have another one on the right behind that's normally behind the rack. So one power supply goes to the left of the left, call it in quote extension, and then the right, the other power supplies goes to the right one. So up to that copper moja. So you have two power supplies on the physical server. One power supply goes to the left side, one power supply goes to the right. So you connect a wire, a physical wire unaweka kwa extension ya right na left. Then from that point, those two power points, the left and the right, they go out of that. I might not be entirely accurate in this, but this is out of the experience I have had in a few data centers. They go to a left wing and and a right wing. What I mean left wing and right wing. So normally data centers will have left wings and right wings, like for each floor. So for example, like for one of the data centers in Nairobi, it has like 4 floors, huge ones. So a whole floor full of servers and racks and shelves. So there's a left wing and a right wing. I hope I haven't lost you guys. So we have come from the physical server, two power supplies, left, right. So that goes, one power supply goes to the right wing of the floor, and the other one goes to the left wing of the floor. Now, what happens in the left wing and the right wing? You have UPS rooms. UPS, a huge room full of UPSs, and then and it's huge UPSs. It's not like the UPS you normally know, the one that you have at the cyber. No, these are huge ones, big ones. You enter a room, and then they are color coded. Like you enter a room, it's orange. The whole room is orange, and the UPSs are orange. And then you go to the right wing, all the UPSs are another color. Then from the UPS rooms, there is a way they can. I'm talking about power alone. This is power alone. The power that is coming to your server. I'm trying to show you guys how this redundancy is set up, just to make sure that your server doesn't go offline. So then you come from the UPS rooms, you go into generators. There are generators that, again, the size of rooms, a huge room. It's not the generator you know of. So this is a generator that is tall as a truck. It's very huge. Like you see these trucks that the 24 wheelers, how tall it is. So unapata generator ni mrefu hivyo. Well, it's not as long as a truck, but it's tall as a truck. And then in a room, amazing stuff that happens there with electrical engineers. They normally are running hot water, or call it warm, within the generators, just to make sure that they never have cold starts. So you have generators, I think, for most DCs, will have a bunch of them, like 3, 4, 5. Then, because of the size of the generators, like, what do you call it? I'm not the best person to explain the DC infrastructure, but the fuel pumps for them, now the fuel tanks, sorry, zinakaa kama zile zinakwanga kwa petrol stations, so it's underground. So that's the tank for the generator. You can get the size now. I hope you guys are imagining the size of the generators. And then now from there, these guys are enterprise KPLC customers, so they have multiple channels of power coming from KPLC, and KPLC cannot make any changes on power, without informing these guys, because their power bills are crazy. They're in the millions. So that's the size of a data center. So, and then you have now two power lines, separate lines coming from KPLC. So you can imagine, so your server, basically kasava kenye kako kwa ile rack pale where we started, it is receiving power from two different KPLC lines. One power supply receiving power from one different KPLC line, and the other power supply receiving power from another KPLC line. And not only KPLC, but as I also explained, two different UPS rooms, and two different generators, which are separated in a sense. And the generators for them, they are backups. So they are normally just there. They are running. Well, I know if you have worked with cars, you know that cars, they have well, you have all used cars at some point, yeah. So in a magical radiator, it's hot, right? So it's the same thing. So a generator will have a radiator, the same thing, but big ones, and then now they are always running hot water, so that whenever there is a power outage, within a few seconds like this, the UPS inashikilia tu kidogo, few seconds the generators kick in, but they are always on standby for that. So let's go to our demo, guys. How many minutes we have? 10 minutes. Yeesh. Okay. Any
So it's
questions up to that point?
okay. So hello. So it's okay. You can
Uh-huh.
don't rush too much. It's fine.
Uh-huh.
Yeah.
Okay, guys. Thanks, Kadima. I'll try to make it short. I hope you guys are finding this insightful. Um, I had actually planned to show you some photos of data centers, but you guys just check them out online. I didn't want to get into trouble. I know that this video might go into will go into YouTube. So if I did some photos of some data centers, unless I buy the credits for the photos, uh, then we might be having we might create trouble for for our video later on. So but you guys can Google and check out the DCs. Can in US now, US is even more advanced than we are. So everything I have explained to you guys, it's in Nairobi. But now you can imagine now what we have in other developed countries. For us, we are a developing one. So, but that's maybe one of the reasons why you will decide to have your servers in a data center and not in your server room. Because, like as the example I shared for me years back when I was in campus, and we had a server room in a particular building in the campus compound. Uh, that server room didn't have those things that I was explaining to you. Well, I think we did. We had backup generators, yes, but the kind of once you're into a DC, you'll see what I'm explaining. That it's not something that you can achieve at home, or you will have to. Yes, you could in a home or in an institution, but you would need to make you know a huge investment to be able to do that. And the data center, what it does, it brings everyone who needs such services together. So you will have even for Google and other guys and big guys, they are in data centers, even in Kenya itself. So kila mtu anatumia the same infrastructure in a sense. So and then you pay the data center, their dues, etc. So let's go to our demo very quickly here. So I want to show you guys three different setups that you could have in a private cloud. Interestingly, private clouds and public clouds are not very different. The only difference is the name: public, private. Private is for your own private use, probably for your own organization. Peke. Public is a private cloud that has been made public. For example, Google probably started with their own private cloud where they had their own servers and they were running them for their own use. Wakazi set up, they grew that. I'm guessing, I don't know, but probably, definitely that's what happened. At some point, they had servers that they were using for their own use. When I mean physical ones. Then with time, probably grew that, and now they probably guys would come to them and ask them, hey, there's a host going or something, and at that point, then they decided, yeah, why not? So maybe pump up the capacity, build more redundancy. Then kidogo kidogo now they're offering it as a service, which is what we call Google Cloud. So where now you're spinning up a machine, or even EC2 again for AWS. It's the same thing. Probably AWS started with their own servers, their own private cloud in quotes, then wakaenda hivyo, and now they are now offering it as a public cloud. So that's the only difference. A public cloud will be open to the public. You can come in, buy your VM, and run your infrastructure. While a private cloud, on the other hand, would be probably for your own internal use. So I want us to see how you could set up a private cloud. There are many ways to set it up, but just want to look at three in passing. And now for our live demo, we will be having one of the examples that I show in this. Uh, So I want this is a question. This one and in nitauliza ndio we make it interesting. Why, guys? I know you can see this diagram right now. Why do you think, guys, we need two switches? It's a simple question. I think it's a no-brainer, or maybe it's not. You can write to the on the chat. Uh, why you think we need uh, we need two switches in this? The first one to get it correctly, nitamtumia kitu kwa M-Pesa. Hey! Ali, umekamata. Nice. Remember to share your number with me, please. You can get my number on the group. Send you something. M-Pesa. Yes, it's for redundancy. Perfect. Perfect. Yes, we need two switches for redundancy. As you can look at it, it's we have two switches connected to different ISPs. You can also guess why we need two servers, two physical servers for the management pool. It's for the same thing, the compute pool. Same thing why we would have that. To explain a bit what I mean or what we mean here by this, all these servers are the same in a sense, in terms physically. It's a physical server. It could be from HP, from Dell, Lenovo, uh, yeah. So they are all the same in terms of from a physical sense. The chuma, and there's a motherboard inside. There are RAM sticks, there are hard disks, etc. But then now, how you set them up, you separate concerns in a sense. So, for example, like now, for you have a management pool, which the management pool, it carries the your management, in quotes, VMs. So management VMs, what they do, they manage the entire infrastructure. So as the name suggests, so you can, if you want to do stuff, which you will always need to do stuff within your private cloud, then you use, or within your cluster. When I say cluster, I mean the cloud. I mean this infrastructure. So I'll use that interchangeably. When I say cluster, I am meaning the private cloud, and when I say private cloud, I mean the cluster at the same time. So you can, you use the management. The management pool carries management VMs. Now, why you need two or more? In fact, it's recommended to have three or more, not even two or more. So for my diagram, I only have two servers in the management pool. That is two physical servers, but it's recommended that you have three or more. So why you need more is because of what Ali said. Same thing for the switches, is you need redundancy. So if switch A goes offline, you still have connectivity to your infrastructure coming through ISP and through switch B. If switch B goes offline, same case, you have connectivity through switch A and through ISP A. For the management pool, same thing. You have two, or you have three or more servers. If one server goes offline, maybe something happens, maybe it may overheat, it may shut down, your VMs will not be affected. So you can still manage the infrastructure because your management VMs, for this case, which are running in the management pool, then they can move to other hosts. That's normally how it's set up. So same thing for compute pool. For the compute pool, to explain a bit of what this is, it is more of where now the VMs that carry the applications are. So as the name suggests, compute, a compute pool. So it's where you store, if you have an Active Directory VM, it will be in the compute pool. If you have a VM that is carrying your POS system, if you're a supermarket, for example, that VM will be in the compute pool. If you have a VM that is carrying email services, probably you're doing Exchange, a Microsoft Exchange, and it's running in a VM, in a Windows VM, then that will be in the compute pool, etc. For the storage pool, this is where, and again, as I mentioned, this is just one way in which you can set up a private cloud. There are many other ways. You'll see them. I'll show you three of them. So this is one. So I'll show you three of them, and then I show you the demo. So this is just one. So the storage pool is where now you have, these are same. They could be the same servers, physically, but then you dedicate them for storage. So you set up, you can set up use network as storage, etc. So there are different approaches on how you can configure your storage, but again, you're aiming for redundancy. So if one storage node goes down, so the VMs in the compute pool, still they can connect to the storage, and they still can run, they can access their data, etc. So if there's any question, Just type it on the chat. So let's go to the next slide. So this is the second way in which I think in which I'll show you today, in which you can set up a private cloud. I mentioned that there are many ways. I'm just showing you three of them, but there are many other ways that you could set up a private cloud. Now for this one, you can see that it's a bit different. So now I will have another question. Napa again, the one who will get it first, I'll send something. I hope it doesn't sound like I'm bribing guys to participate, but no, I just want to make it a bit interesting. So, what do you think uh, would be the advantage of having this setup? What we are having on the screen right now. Uh, this is a bit. It's a more difficult question, but maybe it's not. Why do you think it would be advantageous to have this setup instead of having the previous one? The previous one we had. Let me go back so that you see. Previous one is this, which had a management pool, compute pool, storage pool. Now for this one, we only have a management pool, and then we have everything else in the compute plus storage pool, which is a hyperconverged in a sense. So there are no wrong answers. Give it a shot. Why do you think this would be? Well, it's arguable, but why do you think this would be probably a better approach? Anyone on the chat? Okay, sawa. Let me give you the answer. Hii imekaa ngumu. Okay, but one of the advantages is it's more on the business side. So you need fewer servers. Probably you might need fewer servers. So which means then you save on cost in a sense. It's arguable again because there are other nitty-gritties inside there. There is licensing, etc. But let's go to the last one. So I'm showing you what we have on the live demo. This is another way you could set up. So for us, we don't have a separate management. For the live demo, we won't have a separate management pool. We'll have everything in one pool, so in one cluster. So basically, it's 4 servers. Think of them as 4 physical servers. For the lab demo, what I have done, I've set up something they call a nested environment. So I'm not using. So I have a physical server, yes, but I don't have 4 physical servers for my case because I don't have the money. They are a bit expensive. A server could cost a server with good specs can cost anywhere between with good specs, underlined with good specs. It could cost anywhere between 400,000 Kenya shillings and even say 5 million, 6 million, 7 million Kenya shillings for a good physical server that has good specs. In fact, the ones that are coming out nowadays with the latest Intel chips, they are super expensive. But yeah, but that's the cost you have to pay for compute, man. So now everything else is built on top of that. So you have to pay the price. It's either you do that or you know end up public cloud whereby to VM. And I don't have anything against public cloud. As I mentioned, it has awesome business benefits because you don't have to put up capital and invest 100 million shillings to set up or less, depending on your workloads. You can just buy a VM. But yeah, but there are levels that you get to where you need actually to invest that kind of money and buy physical servers and set them up. So yeah, we have 4 physical servers in our example. We won't look at the network redundancy for now. So the switch A, switch B, I won't go into that, Sana. I'll just want to show you the four hosts, how they look like in a VMware environment. And then probably we can spin up a VM very quickly. I know we are out of time. Yeah, it's already time when we're supposed to. But yeah, Kadima aliniambia nisikuwa na haraka, but I don't want to keep you long. So I'll show you the lab. It has four hosts. When I say host, I mean the physical servers. Understand it? Host equivalent to his physical server. So it has 4 of them. Then we will set up probably we can set up a VM, maybe a Linux VM. Then we can deploy something inside. Well, I know you guys have deployed things inside VM, so probably we can skip that part. We can just deploy a VM or I show you a VM I have already deployed. Then I show you a bit of redundancy on how it works. In terms of we switch off one physical host, then we see what will happen to the VM. So, and then I'll explain these features once I'm done with the demo. So let me stop sharing this one and go to the lab. So any question you can type it on the chat as I log into the lab. Any feedback too? If you're finding I'm moving too fast, you can ask me to slow down.
Okay, I
If I'm
see
moving
on the
too slow,
chat
you can. Uh-huh.
there is Peter who said, I'm yet to grasp how a private cloud is cheaper than a
Mm-hmm.
public cloud, paying attention to
Mm-hmm.
the number of requirements you have highlighted.
Ah, okay. Yeah. So I think when you get let me see. Uh, oh, Alex. Oh, it's Peter who is asking. Okay. Yeah. So kuna msee alikuwa ameanswer the question. I hope you did. There's no. I'm checking at the chat right now, so I hope there's no one who answered the question, and no, and I didn't see it, and they now. Sorry if you answered the question correctly, and I didn't see your chat. But there are other questions which will be coming up. If you can answer the first one. Oh, you answered. Oh, Martin anajitetea anasema alianswer. But anyway, so for let me answer first Peter's question, Martin. So for I'm yet to grasp how private cloud is cheaper than public cloud, paying attention to the number of requirements you have highlighted. Yes. So for let me put it this way. It it varies from business to business, and uh, uh, private cloud is not for everyone. Let me put it that way. In terms of when I mean everyone, I don't mean individuals. I mean private cloud is for everyone in from at an individual level. And that's why we are having this conversation because I want to bring you guys, to show you a few nuggets here and there on how the private cloud works. So from an individual level, all of us, can learn and use it, to some extent. But from an organization perspective, it's not for everyone. Private cloud is for businesses which have gotten to a level where when they do their math from a business perspective, running from the cloud is super way high expensive than having their own physical servers. So when you do those calculations, it's more complicated than I can explain in this one meeting. But there are many factors that you will look at. How much computing power do you need? That's the first question. Data residency, as we mentioned, that's another question. uh, where are your users? Like the example I gave you about the hospital. Uh, you know, will this hospital somewhere down in a valley, great down in the Great Rift Valley somewhere, along Nakuru, Nairobi Highway, would they be willing to host patient data on GCP? And probably they are. I don't know, but will they be willing to host their core management hospital system on GCP and rely on internet service providers for them to be able to connect to their system? And I think the answer to that is no. So they will have to weigh the scales and say, hey, manze, upper for us, we just have to go the hard way where we are at. But for a small clinic, let me now use that example. For a clinic that is just getting started, a few branches here and there, and probably all those branches are in places where it's not remote. Then for those clinics, then it makes sense for them to host on public cloud, have a few VMs running, and they are hosting their all their systems on. Oh, sorry guys, I'm somewhere outdoors, so I don't even know what that is. Hope it's not something that can eat people. But anyway, so uh, so yeah, so I hope I answered your question, Peter. Yeah, but yeah, we can have further conversation on this. You can get my number, we can chat a bit. It's on the group. So let's go back to this. Oh, I was about to log in. I didn't even log in. I started explaining stuff. So if you have no further questions, probably you want us to discuss, you can reach out to me privately. Then we will chat. And so that you don't keep everyone in the meeting. Okay, am I not able to log in? I've forgotten my password. We have a hacker in the house, aniambie password yangu. Okay, fine. Let's see, just a sec. It's loading. Loading.
You can you stopped sharing.
Okay, let me share my screen. This piece here, share. Loading. You can see my screen. There's a loading screen.
Yes, yes, yes.
Or you can't
I
know
can
whether
see it.
it's Google Meet which is loading or it's a lab. I think this is a lab which is loading. Let's see.
Yeah.
Just
I
a
can
sec.
see a blue spinner.
Ah, yes. There we go.
Okay.
So you can see it.
Yes, yes, we can.
So perfect. Mm. Hmm? Mbona? Just give me a sec. Let me stop sharing and then try and type some comment, some bunch
Okay.
of combinations here. I don't know what's happening to my password. This is weird.
Okay. So Jenny is saying you forgot to sacrifice to the demo gods.
Yeah, maybe, man, I did. Ah, okay, let me think. Am I putting the wrong password? Okay, no. Let me type it somewhere, Mali, in plain text. I hope I'm not sharing my screen.
Oh no, you're not.
Okay, perfect. So I'm typing in plain text. Let me copy paste. This doesn't work. I don't know what I put as the password then. Why? Okay, let me try without that. That doesn't work. Okay, let me try. Nilikuwa nimelogin. Local. This is weird. Okay, they're saying I close and try from a new window. Maybe that will help. Okay, let me try a new window. This is not the one. This is 61. Loading. Give it a sec. Launch this client. I think probably don't know what happened over there. It's loading. Let's see. Let me see. Just a sec, guys. It's loading. Tumerudi kwa ile screen ya kuload. Let me share my screen again. See what will happen. It's still loading. Okay. It's 9:14. Okay, there we go. Let's see. I think it worked. Hallelujah, it did. I think I just needed to open a new tab. Okay. Okay. We chose this life of now trying to troubleshoot just opening a new tab. That's the problem. You need to close the tab, open a new tab. It works. That's the solution. Restart your laptop. Restart your machine. Let's see. I'm making fun. By the way, in cloud, you before you restart something, you have to be really sure. Yeah, you don't restart stuff very quickly. Remember when I was new in this, I used to see a problem, as a system admin in a sense, and then the first thing I think, let me restart this VM. Then only to restart the VM, and then it's carrying like 50 different customers for with 50 different cPanels, for web hosting. So I restart the VM and then I bring down 50 customers. Guys are calling in, hey boss, what's happening? Our website is down, and I'm there. I'm smiling in the office, thinking I have fixed the issue by restarting. Anyway, let's see. Now we're in. So I remember being reprimanded and being told, don't restart stuff. Make sure you get to the logs and check what the problem is before you restart. I thank God for my boss then. He was very harsh, but it was very helpful. So we are on here, guys. You can see my screen.
Yes, we can.
Perfect. So this is the four hosts I was telling you about. I don't know why I have alerts. I think it's because I had powered down the lab just to save on power. So the lab was off. I just powered it on before the meeting. So let me just reset these ones. How can I? Okay, but these are not big issues. It's just because of those power issues. So you can see the four hosts. So we have a cluster, as I mentioned, that looks like okay, I can't shift my tab. I would have to stop sharing. But yeah, as I mentioned, we have four physical hosts: 1, 2, 3, 4. So there is .151, .152, .153, 154. We have two VMs in the infrastructure as of now. So there is Ubuntu 22. There's a VM called Ubuntu 22. I have just named it that. You can name it anything. And there's another VM I have named vCenter. For those who have worked with VMware, you would know vCenter is one of the management VMs. In fact, vCenter is what is carrying this lab. So I don't think you can see my URL, but yeah. So the vCenter is what is allowing us to see this UI. So the vCenter is a VM, a management VM that allows you to manage your entire infrastructure. So as I mentioned again, we have four physical hosts, and you have one example VM here. So you can have as many VMs as you need. Then just to give you an example of what we are looking at here, you can see if I click on the cluster, you can see the capacity I currently have. So the CPU, it's 31 gigahertz, or 35, not much. This is kidogo, man. This is really small. For RAM, I have around 112 GB, and then for storage, I have around 445, 49 GB of capacity. This is extremely small, but it's acceptable for a lab. So you can have VMs that now the VMs that we'll have in this cluster will basically be taken from this pool. So you can have VMs that would that can total up to a capacity of 112 GB of RAM on this one cluster. So this is again very small. uh, yeah, you can have even one physical host, like if you pick one like this one, so you can check the specs that we have on one of the hosts. This is a physical host in a sense. As I mentioned, for me, it's I have done some maujanja so that I can show you this lab. So it's not a physical host in a sense, but yeah, for the sake of this lab, understand it as a physical host. But yeah, it's so for this physical host, it has around 24 GB of RAM ikiwa peke yake. So this is 24. I think 152 need 24. 153 has around, I think, 32 GB of RAM, and 154 has 32 peers. So 153 has 32 and 154 has 32. So in total, then you get the total capacity, which is what the cluster has. Now, to give you to set things in context, you can, for a physical server, most of them, they will come typically with 24 slots of RAM, 24 physical slots, and then you can have, nowadays you can have even one stick, one RAM stick for a server can be even up to 32 GB. So if you guys can do the quick math, 32 multiplied by 24. So in one server, one physical host, you can have a total of around 768 GB of RAM. So 768 GB of RAM in one physical host. Then now you can now do the math. If you have 10 physical hosts, you can see you have around 7.6 TB of RAM. Yeah, there are things moving around me, man. I'm scared. Don't know what's happening, but okay. Anyway, I'm worried. I'm outside somewhere. Anyway, let's go back to our lab. So now, what I want to do is we power on this VM very quickly, and then so to deploy a VM, I wish we had time. I'll show you how to deploy it, but it's very easy. So you just run an ISO file. It's the same way you will install an OS in a laptop. So in a laptop, how do you install an OS? Probably make a bootable disk, put it in a laptop, boot up the laptop from the flash disk, then install the OS on the laptop, and then remove the flash disk, and you can boot into the OS, right? So it's the same way. How do you set up a VM? You come create a VM. Let me show you very quickly. For example, so you can come new action, create a new virtual machine. Um, we won't run the whole steps for installation because it would take a lot of time. Let me show you how you set up a new VM. Hey, why is it loading that much? It's super slow. It's supposed to be like click, click, kiendanga, click, click, bang. Okay. It's not working. I don't know why it's moving that slow. I might have to reload the page. My VPN online. Let me check my VPN. VPN is fine. What's up? So anyway, but as I mentioned, so you spin up a virtual machine in environment, you insert an ISO. So an ISO is, you would think of it as the flash disk that you insert into a laptop as you install in the OS. You run the installation steps. After that, you have your VM running with whichever operating system you need it to run. It could run, a VM can be running Windows Server operating system. It could be running Linux. I know you know these things from probably using the other public cloud guys. But yeah, so it's the same thing here. And then you create templates. So a template of a VM is basically now what you can use to, you don't have to run the installation steps again. So you can always use that template to create a VM of the same operating system. So let me now go to the, I don't know I think it's my connectivity. Unfortunately, I'm way away from home. So I'm now having to connect to that lab, so things are a bit slow. I would have wished I was at home, so it would be easier. So it would be click, click very fast. So my connection is a bit shaky. But if I can do it, I'll just set up the Nini. Or alternatively, guys, if you can allow me, we can end the call here, and then Kadima, if you can allow me, I can share with you a link to to um, to a to a YouTube video that I had recorded of another lab I had some time before. It's on YouTube, Pilieka Kitambo. It can show you guys a bit on what I wanted to show you today, because now definitely the connection is slowing us down. On how you can have such a you can switch off one of the host, and then you actually switch off the exact host that has that VM. You switch off that host, and then you see what will happen to the VM. So that's what I was doing in the video. So I was switching off the physical host that is carrying the VM, and then which is what I wanted to do here, but clearly we are moving a bit too slow. So I switch off the host that is carrying the VM, the physical host that is carrying the VM, and then that VM migrates very quickly to another host. And I remember it was a few like 30 seconds of downtime for my lab setup, which is not acceptable for a production setup. So in a production setup, you would have a few seconds, VM ishaamka isha restart. In fact, if you have, and it's very rare to have, not rare really, let me rephrase. Um, yeah, so if you have set up your environment the way it's supposed to be, then that time, recovery time, goes very low. So it's supposed to be a few seconds, and that VM is restarted somewhere else. So there's a way VMware will keep a heartbeat on the VM, and then this is extremely slow. Guys, unfortunately, I can show you now here. So will you allow me to share the link, maybe even right now on the chat, and you guys can watch the video? Is that okay, Kadima?
That is fine.
Yeah, let me look for that video just right now. Unfortunately, I wanted to show you live up, but my connection, the problem is the connection between me and my lab. So I'm using the same connection for this call. I'm trying to connect remotely to the lab. So then the lab, now my connection is becoming extremely slow. Now I can't load even the center. Well, it's loading, but it's taking forever. Anyway, so yeah, so I think that's it from my end. Unless there's any question, as I look for the link to share that video. Yeah, I'm actually on YouTube right now looking at the video. So, but as I mentioned, the video, what I'm doing there, you can just fast forward to Comwisho. I'm just switching off the host, then the VM migrates to somewhere else. So that's what I wanted to show you guys today. Unfortunately, I have connection issues. There is no question. I think I'm done. Thanks again for listening to my long speeches here.
You're welcome.
Back
So
to
thank you so
back to you.
much for. Okay, good. Thank you so much for the presentation. So there is a question here from Eric. Apart from VMware, are there any other solutions for private cloud? Samuel?
Yes, they are. Yes, they are. Eric. There's actually even one. One of my other favorites. It's called CloudStack, which is open source. So CloudStack is free of charge. Okay, it's not free, but you understand what I mean with free. Like you don't have to pay for licenses. So there's CloudStack, but there's always something to give. So VMware is enterprise standard. You for the licenses. But there are ways normally to, like if you want to run to a lab, VMware allows you. There is something called VMAG Advantage, where as a VMware, that VMAG is VMware user group. So if you need to follow up around that, let me know. So it's a group that you can join for VMware users. In fact, we have a group for Kenya for that. So and then as a VMAG member, what happens is that you can get the VMware licenses for your lab, at a cheaper rate. In fact, you just pay a small fee, then you're given all the licenses for all the products, and then you can play around with them. There's actually one good product called VMware Tanzu, which allows you to run Kubernetes on top of VMware clusters. So hopefully, maybe sometime in the future, I can show you a bit on that. So it's the same thing. You have a physical, you have a cluster, but now on top of that cluster, you have you have VMs that act as the Kubernetes nodes. So you see, like the way you have, you go to GCP and you set up a Kubernetes cluster, and then you spin up. You're given 3 or 4, depending on what you select, nodes for your Kubernetes. The same thing, but now on the VMware side, there are VMs within your infrastructure. So, but again, remember these VMs, they are supported by the redundancy that you have set up. And then now on top of those VMs, then you run your pods, and now you do everything else that you're normally able to do on Kubernetes. Yeah. So to answer your question again, Eric, yeah, they are there. Check out CloudStack if you may. It's open source. So if you have a small place where you can a bit of computing power, kidogo too, even if you have a machine that is running that you have 16 GB of RAM somewhere lying somewhere. You can even get a desktop. In fact, I think for me the way I started with CloudStack, I had they're called Intel Nukes. So an Intel Nuke has around 8 GB of RAM. If you know Intel Nukes, they are very tiny, tiny PCs. So I was using that. In fact, I still have some of them. So and then I install CloudStack inside there, play around with it, create my VNs, do blah 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 blah, and then okay, then same thing for VMware. Okay, VMware needs a bit more computing capacity, but CloudStack haina hizo you can check it out even with a very small footprint in terms of computing power. Yeah, I hope I answered your question. Yeah, and there are others. There's OpenStack, which is also open source. Which other one? There's Scale Computing. This is Scale Computing is an awesome one also, but I haven't worked with it, sana. Yeah. Kadima, back to you, please.
Okay, thank you so much. So you are supposed to share the link. I think some people are requesting for it on the chat.
Oh, Pole. I started answering question and forgot about the link. Let me see. It is. So it's just a 5-minute video. It's not long. You can actually watch it. It has the ending of the video that I'm sharing is not very ceremonious. Ili cut too, but yeah, you get to see what I mean about redundancy.
Okay. So thank you. So I think that brings us to the end of the session. So if any of you guys is not in our group, let me share the socials for the group so that you can scan and join the group. But for the rest, if you're already in the group, feel free to drop and see you in the next one. So for those who are new to the group, you can join our groups. Just scan the QR codes and you'll be able to join. Okay, bye-bye guys and have a good night.
Good night.